All right, so this is what my journal page ended up looking like. I just cut the work off and taped it right here. But if you want to see it, it looks more like this. At the very top, it looks like that. And then I've scrolled down and it looks like this. So now I'm going to go backwards to work with the waffle story problem that we started with. Okay, so I'm going to come back to the front page of this where it says dividing with fractions, and we drew those waffles about Marston's family. So we did a fair share in this situation. Okay, so what if there were, well, I mean, you would know what to do in this situation. So what I'm going to do here is I'm going to say, what if there are 8 waffles to share? Let's kind of draw, what do I want to do here? I think I just want to draw a pink cutoff line all the way across. So now we know from Marston's family they shared those. But what if we had somebody who made 8 waffles, but there was only 7 people sharing them? So what if someone, well, actually we'll say this. What if there were 8 waffles to share among, that means with, 7 people? What if there were 8 waffles to share among 7 people? So this is the new problem, the new story problem. So we're going to do the equation and a model. The equation, are we going to cut up waffles or are we going to cut up people? We're going to cut up waffles. So we begin with 8. Now we're going to share them or cut them up, cut up the waffles to give to 7 people. This is a whole over whole. We're writing the equation as x. So the equation becomes 8 over 7. And 7 goes into 8 once with 1 little piece left over. So each person will get 1 and 1/7. That makes sense because there are more waffles than people. There are more than enough. In the last problem we did up above, there was not enough. They had to share and only get a fraction. But in this one, there's more than enough. They're going to end up with a whole waffle plus some more. And I know this is your favorite part. We are going to model what that looks like with holes. Okay, so we have to draw how many waffles there were. There are 8 waffles. Let's draw them a little bit smaller. 1, 2, 3, 4, 5, 6, 7, 8. Get all your waffles drawn. And let's highlight all of them because we get to have all 8 waffles. Now there are 7 people who want those waffles equally. So this is actually really easy to me because you just go, okay, well, person 1 can have this one, person 2 can have this one. See how this is working? So if we just start doing it like this, person 1 can have that one. Person 2 can have this one. Person 3, so how many waffles are they all going to get? They're each going to get their own. Plus, they're going to end up splitting up the last one. And now we stop here. Because we say, all right, they each got their own, so they all got 1 whole. But how do you show that they all got a 7th of this one? You don't divide this by 8, you divide it by how many people want it. 7 people want it. So you have to have 7 little pieces. That means you gotta draw 6 lines, just so you know. So each one of these little pieces is gonna be a 7th, right? That one's gonna be a 7th. The next one's gonna be a 7th. and so on and so forth. So you're going to do what's called a fair share over here. And everyone is going to get one of those little pieces. So I am going to color it because technically this is waffle number 8, but they all don't get the whole waffle. They all get a 1/7 of that waffle because there's 7 of them. This waffle needs to be equally split up so that every person can have their fair share. So I am going to write this one right here. They all get one whole, they all get one whole waffle plus their piece of this one. That's how that works out. So they all get one full waffle plus their piece of this one. So you deal out, then divide. So I dealt out the waffles. I said, you get one, and you get one, and you get one. I dealt out all the waffles, and then I say, then I divide what's left. So this is going to be called deal out and divide. Deal out, then divide what's left. That helps me remember what it is I'm doing here. I'm dealing out and then dividing what's left. On the one above with Marson's mom, they couldn't deal them out. They didn't have enough. So they had to begin by doing whole over whole, by splitting them. But this one, there was more than enough. So you had to deal out, then divide what was left. Hopefully that situation makes sense when it comes to the waffles. My favorite thing is what we're doing next. So if you turn the page, we already have something on the back page, right? So we're going to actually be using the front page for this one. For this one, we're still going to deal with equations and modeling, but we're now going to make it a little more, like a little more complicated, I would say. So let's continue. So we're just going to write continue dividing with fractions. You don't have to put the date or anything on here because it's the same thing that we've been doing. I'm just going to do this. Use the same colors. We're continuing to divide with fractions. That's what we're doing here. Okay? All right. Let's stop talking about waffles and candy bars and let's go with cake. All right? Let's write this story problem. I know that my voice is a little behind the actions in these videos, and so I'm just going to write the story problem, and then at the end, we'll read it all together. The first sentence says, there was 1/3 of a cake left over in the fridge. Here's the next sentence. Next sentence is, 4 kids wanted to share it. Here's the question. The question is, how much of the whole cake did each kid get? Okay, so we're going to write an equation and we're going to model it. So here we go. Let's put this in like a, well, I don't know. I kind of wanted to put it in its own little box so that we know that this is the story problem. But I'm just going to make little brackets. Okay. This is the story problem. So we're going to write the equation. And over here, we're going to model it. All right. The equation. Do you think about this? Do I start with the kids and cut them up? Or do I start with the cake and cut it up? Hopefully you said the cake. You start with the cake and you're cutting it up, which means you're dividing it, and you're sharing it with 4 people. Remember how the last time we did this lesson, if you start with a fraction, you should end with a fraction. If you start with a whole, you should end with a whole. So we're going to be ending with a fraction, right? We just don't know what that fraction is yet. So equals x. Well, let's go ahead and continue to solve that. Remember this, when you divide by a fraction, here's a tip. You keep the first number, change divide to multiply, and times, and you're going to multiply by the reciprocal. So you take the other one and you flip it. So this, when you're doing this, goes like this. Some people have called it copy dot flip. Some people say it this way, keep, change, flip. Some people say it this way, keep the first number. Whatever it is, keep the first number. Change divide to multiply. Then times by the reciprocal. I said that a little funny. Then times by the reciprocal. That number reciprocal we've used before, just earlier today. Keep the first number. Change divide to multiply. Then times by the reciprocal. That is what actually is happening. And then these are the shortcuts. Keep, change, flip, or copy dot flip. So if I'm trying to use one of these things to solve the problem, I'm probably going to go with the one that's easy. Keep, change, flip. Keep the first number, change that one to multiply, and flip this one. So copy dot flip means copy 1/3, then put a dot, which means times, then flip it. How do you flip 4? Well, right now, isn't there an imaginary 1 underneath it? So you change 4 to be 4 over 1. That's what it is right now. So you have to change it. The reciprocal of it would be 1 over 4. To keep, change, flip, you keep 1/3. You change divide to multiply. You flip this number. So to flip 4, instead of 4 being on top, 4 becomes on bottom. Or keep the first number. Change divide to multiply. And times by the reciprocal. The reciprocal of 4 is 1/4. So I just walked through all of these so that you would know any of them that we refer to. If we say keep, change, flip, that's exactly what we're doing. All of these are the same. So the answer to all of these problems, every single one of them, is 1/12. That is the answer to all of those problems that we just did. So x is 1/12. Okay, so I ended with a fraction. So I started with 1/3 of a cake, and I shared that with 4 people, so they all got 1/12 of a cake. That makes sense. But to model it, remember when you model a fraction, you have to draw the whole cake so that you can prove that it was 1/3. So in order to model it, let's just draw a really long, really long cake. My cake isn't round. My cake's going to be rectangular. Rectangles are always easier to cut, even in real life. Here's the model. Ready? I have 1/3 of this cake. Right now, this is a whole cake. So to show 1/3 of it, I'm going to color in one of those thirds. I always just start on the left. Just a habit that I have. Make sure it's colored nicely. So I have 1/3 of the cake. So this amount is 1/3. That makes sense. So I take the 1/3 and I split it with 4 people. So we're going to write this out in words. I know it's a lot of writing, but it will help you later if you get confused at home or during your assignment. So split the 1/3 piece into 4 pieces. So each kid can have one. That's called fair share. So let's do that right now. Split that into 4 pieces. Nice. I just kind of made my eraser make it look like dashed lines. So I now split that so that each kid could have one. All right. So this is going to be kid 1, kid 2, kid 3, and kid 4. So you have kid 1, kid 2, kid 3, and kid 4 who all get those. But you also have to, this is going to be really critical, then split the whole cake into equal size pieces. I'm going to say into those same size pieces. Those same sized pieces. So now I go, okay, well this one was cut into 4, so this other one has to be cut into 4 as well, and so does this one. So I hurry and do that. If you want, you can make them look like they're dashed lines, because technically that cake's not even there. But if it was there, this is the size pieces that it would be. Okay, so I've now cut the cake into equal size pieces. So this is to see how many there would have been. So then split the whole cake into these same size pieces. So the denominator is how many there were in the whole cake. So we'll just say the numerator is how many each person got. In our case, they got 1 piece. The denominator The numerator is how many each person got. So they each got 1 piece. The denominator is how many equal size pieces were in the whole. Not in the purple part, but in the whole cake. There were 12. Because this is 4, this would be 4, and that would be 4 as well. So if we want to number them, we can. So there would be 12. So your final answer is 1/12. So when I only have a fraction to start with, make sure to draw the invisible rest of the whole and split that into equal size pieces as well. That's going to be really, really important. So the numerator is how many each person got, and the denominator is how many equal size pieces were in the whole. So you just cannot forget to split up the rest of that whole, or you're going to get the wrong answer. So be really careful when you're dividing with fractions that you do that part correctly. Okay? So at the end of this, we're almost to the end, we're going to watch a little video clip. We're going to watch it on my phone actually, and I'm just going to project it through the video. But it's one of my favorite math videos, and it's called Dividing Fractions, and they use this phrase, keep change flip. And I want you to remember a phrase that's in here. It says that dividing with fractions is not done magically, but it is done mathematically. So we're going to draw some little music notes here, and I want you to listen for that phrase or something that's really similar to that phrase, so we can figure this out, not magically, but mathematically. Because sometimes kids watch this video and they're like, oh, it's like magic. It's just a quick trick. Any quick tricks in math are not magical. They're mathematical. So dividing with fractions. Actually, it might be helpful for us to write the whole phrase. Oh, I'm so sorry. We're going to erase this. I'm going to freeze it so you don't see it shaking around. But go ahead and erase what I just wrote, which was the dividing with. So you'll see in a minute. Erase it. So we're going to say, to divide with a fraction, here's a tip. We'll say to divide by a fraction. I think that's what the video says. Here's a tip. And here's what they do. You ready? Keep, change, flip. And then they say something about it being mathematical, not magical. I love that part of the video because it's so true. Sometimes when we find these quick little things in math that are like, oh, it's like a quick trick. Remember, those tricks always have some sort of meaning. We talked about that when we compared fractions. How sometimes you think you could just cross multiply, but really what's happening is you're finding a common denominator. So just really cool. So to divide by a fraction, here's a tip. Keep, change, flip. All right, you ready to end this lesson with the video? When the video is over, I'll explain what to do next. Also, it's going to be a little delayed, so I'm also going to put the link to the video in Canvas, and you're welcome to watch that video on your own as well, if this is just driving you crazy that it's so delayed. But okay, here it is. We're going to zoom in a little. I have to tilt it like this for you in order not to get a glare, or maybe I could turn off the light. Let's try that. Oh, that's pretty cool. All right, you ready? Here we go. Make sure it's all the way turned up.
To divide by a fraction, here's a tip. Keep, change, flip. To divide by a fraction, here's a tip. Keep, change, flip. To divide 1/2 by 1/6. Keep, change, flip. 1 times 6 is 6, and 2 times 1 is 2. It's an improper fraction, so we're not through. Divide 6 by 2, and the quotient is 3. Keep, change, flip. It's all that you need. To divide by a fraction, here's a tip. Keep, change, flip. To divide by a fraction, here's a tip. Keep, change, flip. To divide 2/5 by 1/5. Keep, change, flip. 2 times 5 is 10, and 5 times 1 is 5. It's an improper fraction, so you need to divide. 10 divided by 5 equals 2. When we divide by fractions, this is what we do. To divide by a fraction, here's a tip. Keep, change, flip. To divide by a fraction, here's a tip. Keep, change, flip. Keep, change, flip. Keep, change, flip may seem to work magically, but it can be explained mathematically. With the number 10, we can divide by 2, and that will leave 5 in each group. Or we can find that 5 through a different path by multiplying 10 by 2, flip to 1/2. It's the trick that never fails, called keep, change, flip. It's real math magic, so use this tip.
We understand with these problems we love, because we know division means has how many groups of.
Let's explore that thought. How many groups of fourths does 1/2 got? 2 fourths fit into 1/2 perfectly, and we found the quotient mentally. To divide by a fraction, here's a tip. Keep, change, flip. To divide by a fraction, here's a tip. Keep, change, flip. To fraction, here's a tip. Keep, change, flip. To divide by a fraction, here's a tip. Keep, change, flip.
Wasn't that so fun? Okay, so you already have the homework and remembering because we did the remembering from yesterday. So we are just going to look at the homework side, and you can do the keep, change, flip because now you've learned all the modeling and why it works and blah, blah, blah. So I wouldn't do keep, change, flip when it comes to whole numbers. I would just do whole over whole, whole over whole, whole over whole. If it's something like that, you're going to have to fix it. This one is also whole over whole. So some of these are going to be so fast. In fact, maybe you could go through and find all the wholes over wholes. Like number 8, whole over whole. Easy. Then it becomes not so easy. So let's take a look at number 2. So you have 9 candy bars, and you're going to cut those 9 candy bars into fifths. How many 1/5 size pieces will you have? The answer is 45, but you could do this. To divide by a fraction, here's a tip. Keep, change, flip. To take 1/5 and flip it would be 5 over 1, which is just 5. So that's proving that it is 45. Same thing if I had 8 candy bars and I cut the candy bars into 6. How many 6 would I have? Keep, change, flip. Okay, let's do like number 12. What starts the fraction. I have a third of a cake and 5 people want to share it. Keep the first number, change, and how do you flip 5? It's 1 over 5 instead of 5 over 1. So it's 1/15. That makes sense. I didn't have very much of a cake and I shared it with 5 friends. So that makes sense. I want to do number 15 is a pretty good one. Number 15. Nayati, that's a cool name. Nayati wants to swim 50 miles this school year. This is what she wants. She plans to swim a 1/4 mile each day. Then I know her portion size, or I know how much she wants to do each day. How many days will it take her? So do I take the miles and cut it up by the distance? Yeah, you want to put what she's starting with. So she wants to go 50 miles. And each day she's going to split up those miles by going a 1/4 mile each day. So to divide by a fraction, here's a tip. Keep, change, flip. Pretty easy. How many days is it going to take her to go 50 miles? It's going to take her 200 days, and that makes sense. She wants to go pretty far, and she's only going a fraction of a mile every day. So it is going to take her 200 days. You don't have to put that into a sentence. You can just do it like that. So hopefully you enjoyed that math lesson. You need to finish the homework side of 3.10. See you next time.